The National Electrical Code, specifically Article 410.30, addresses the connection of fixtures to junction boxes using flexible cords. According to the NEC, fixtures can be connected to a junction box by a flexible cord if the cord is of an approved type, for example SO, SJ, SJT, SVT, or SVW. The cord must be suitable for the connected load. The cord must be securely attached to the fixture and junction box in a manner that prevents strain on the terminals. The NEC does not explicitly address the direct connection of high-bay fixtures to junction boxes using manufacturer-supplied cords. However, based on the general requirements, it would appear to be permissible in certain scenarios. Firstly, if the manufacturer's cord is of an approved type for the intended use, for example, SU cord. Secondly, if the cord is rated for the load imposed by the fixture and ballast. And thirdly, if the cord is properly attached to the fixture and junction box using approved connectors. The weight of the fixture should be taken into account when making this connection. If the weight exceeds what the junction box and screws can safely support, an additional support must be provided, such as a hook or other suitable method. To ensure safety and code compliance, it is recommended to consult with the manufacturer's installation instructions and local building codes before proceeding with this type of installation. Additionally, it is advisable to use a strain relief device or other means to prevent strain on the cord connections. When considering an electrical installation, it's important to consider several factors to ensure safety, code compliance, and optimal performance. Firstly, conductor sizing. The size of the conductors used must be adequate to carry the intended load. This is governed by NEC Table 310.15b16, which provides ampacities for various conductor types and sizes based on insulation type and temperature rating. Factors such as ambient temperature and the number of current carrying conductors in a raceway can affect ampacity, requiring adjustments as per NEC 310.15b2 and 310.15b3. Secondly, overcurrent protection. Circuit breakers and fuses protect conductors and equipment from overloads and short circuits. The overcurrent protection device must be sized appropriately for the conductor ampacities specified in NEC 240.4. It is generally permissible to use the next highest standard overcurrent device rating if the conductor ampacity does not correspond to a standard breaker or fuse size, provided certain conditions are met as outlined in NEC 240.4b. Thirdly, grounding and bonding. Proper grounding and bonding are crucial for safety. Grounding ensures a low impedance path for fault current to return to the source, allowing overcurrent devices to operate and clear the fault. Bonding connects non-current carrying metal parts to create an electrically continuous path, minimizing voltage differences and shock hazards. NEC Article 250 provides detailed requirements for grounding and bonding systems. Fourthly, wiring methods. The choice of wiring method, such as conduit, cable, or raceway, depends on the application and environment. Each wiring method has specific requirements regarding installation, support, and protection. For example, rigid metal conduit provides excellent physical protection but requires specialized tools for cutting and threading, while flexible metal conduit is easier to install in tight spaces but offers less physical protection. NEC Chapter 3 covers various wiring methods and their installation requirements. Fifthly, box fill calculations. Junction boxes and enclosures must be sized adequately to accommodate the conductors and devices contained within them. NEC 314.16 specifies the rules for box fill calculations, taking into account the number and size of conductors, device yokes, and internal cable clamps. Overfilled boxes can lead to insulation damage, overheating, and unsafe conditions. Sixthly, voltage drop. Excessive voltage drop can negatively impact equipment performance, causing lights to dim, motors to run inefficiently, and electronic devices to malfunction. NEC 210.19a on FPN4 and 215.2a3 FPN2 provide guidelines for minimizing voltage drop in branch circuits and feeders. Generally, voltage drop should not exceed 3% in branch circuits or 5% in feeders. Seventhly, environmental considerations. The environment in which the electrical system is installed can significantly impact its performance and longevity. Factors such as temperature, humidity, corrosive substances, and physical hazards must be considered when selecting equipment and materials. For example, in damp or wet locations, weatherproof enclosures and wiring methods must be used. Eighthly, equipment listing and labeling. All electrical equipment and materials used in an installation must be listed and labeled by a recognized testing laboratory, such as UL or ETL. Listing and labeling indicate that the equipment has been tested and found to comply with applicable safety standards. NEC 110.3b requires that listed and labeled equipment be installed and used in accordance with the manufacturer's instructions. Ninthly, accessibility. Electrical equipment such as panel boards, disconnects, and junction boxes must be readily accessible for inspection, maintenance, and repair. NEC 110.26 specifies the working space requirements around electrical equipment, ensuring that qualified personnel can safely access and work on the equipment. Tenthly, coordination. Coordination of overcurrent protection devices is essential to minimize service interruptions. Properly coordinated systems ensure that only the overcurrent device closest to the fault opens, leaving the rest of the system unaffected. Coordination studies, often involving time current curves, are used to determine the appropriate settings for overcurrent devices. 11thly, arc flash hazard analysis. Arc flash is a dangerous phenomenon that can occur when a fault in an electrical system creates a high-energy arc. Arc flash hazard analysis is used to determine the potential arc flash hazards and to select appropriate personal protective equipment. NFPA 70E provides guidance on arc flash hazard analysis and safety-related work practices. 12thly, load calculations. Accurate load calculations are essential for determining the size of the electrical service and distribution equipment. NEC Article 220 provides detailed rules for calculating the various types of loads, including general lighting, receptacle outlets, appliances, and motors. 13thly, emergency systems. Emergency systems, such as emergency lighting and backup power, are designed to provide essential power and lighting during power outages. NEC Article 700 covers emergency systems and specifies the requirements for their installation and operation. 14thly, special occupancies. Certain occupancies, such as healthcare facilities, hazardous locations, and places of assembly, have special electrical requirements due to the unique risks associated with these environments. NEC Articles 500 through 590 address these special occupancies. 15thly, energy efficiency. Energy efficiency is an increasingly important consideration in electrical system design. The NEC contains provisions related to energy efficiency, such as requirements for lighting controls and high-efficiency motors. Additionally, various energy codes and standards, such as ASHRAE 90.1, provide detailed requirements for energy-efficient design. To ensure compliance with the NEC and other applicable codes and standards, it is essential to consult with qualified electrical professionals. Electrical engineers, contractors, and inspectors can provide valuable expertise and guidance throughout the design, installation, and inspection processes. Remember, working with electricity can be dangerous. Always de-energize circuits before working on them and follow safe work practices. If you are not qualified to perform electrical work, hire a licensed electrician. Let's consider the specific scenario of connecting high bay fixtures directly to junction boxes using manufacturer-supplied cords in more detail. First key consideration is the type of cords supplied by the manufacturer. The NEC requires that flexible cords be of an approved type for the intended use. Common types of flexible cords include SO, SJ, SJT, SVT, and SVW. These designations indicate the cord's construction, insulation type, and voltage rating. For example, S cords are service cords, SO cords are service cords that are oil resistant, SJ cords are junior service cords, SJT cords are junior service cords with thermoplastic insulation, SVT cords are vacuum cleaner cords with thermoplastic insulation, and SVW cords are vacuum cleaner cords that are water resistant. In the case of high bay fixtures, the manufacturer typically supplies a cord with a designation such as SU. The SU cord is a service cord, junior grade, oil resistant, and water resistant. This type of cord is suitable for use in damp or wet locations and is resistant to oil and other chemicals. The second key consideration is the cord's ampacity rating. The cord must be rated for the load imposed by the fixture and ballast. The ampacity rating of a flexible cord is determined by its size and insulation type and is listed in NEC Table 400.5a. The ampacity of the cord must be equal to or greater than the calculated load of the fixture and ballast. For example, if a high bay fixture draws 2 amps, the cord must have an ampacity of at least 2 amps. It is always a good practice to use a cord with a higher ampacity rating than required to provide a safety margin. The third key consideration is the method of attachment. The cord must be securely attached to the fixture and junction box in a manner that prevents strain on the terminals. This is typically accomplished using cord connectors or strain relief devices. Cord connectors are designed to grip the cord tightly and prevent it from being pulled out of the fixture or junction box. Strain relief devices provide additional support to the cord and prevent strain on the terminals. When selecting cord connectors and strain relief devices, it is important to choose ones that are specifically designed for the type and size of cord being used. The fourth key consideration is the weight of the fixture. The weight of the fixture should be taken into account when making this connection. If the weight exceeds what the junction box and screws can safely support, an additional support must be provided, such as a hook or other suitable method. The NEC does not specify the maximum weight that a junction box can support, as this depends on the box's construction and mounting method. However, it is generally recommended to use a heavy-duty junction box and to provide additional support for fixtures that weigh more than 50 pounds. In many cases, it is necessary to install a hook or other support directly to the building structure to support the weight of the fixture. The fifth key consideration is compliance with local codes and manufacturer's instructions. To ensure safety and code compliance, it is recommended to consult with the manufacturer's installation instructions and local building codes before proceeding with this type of installation. The manufacturer's installation instructions will provide specific guidance on how to install the fixture safely and correctly. Local building codes may have additional requirements that must be followed. In addition to these key considerations, there are several other factors to keep in mind when connecting high bay fixtures directly to junction boxes using manufacturer-supplied cords. Firstly, ensure that the junction box is properly grounded. Grounding is essential for safety and helps to prevent electrical shock hazards. The junction box should be grounded in accordance with NEC Article 250. Secondly, use proper wiring techniques. All wiring connections should be made in accordance with NEC Article 110. Connections should be clean, tight, and properly insulated. Thirdly, protect the cord from physical damage. The cord should be protected from physical damage such as abrasion, cuts, and impact. This can be accomplished by using conduit, raceway, or other protective measures. Fourthly, inspect the installation regularly. The installation should be inspected regularly to ensure that it is in good condition and that there are no signs of damage or wear. Any problems should be corrected promptly. By following these guidelines, you can safely and effectively connect high bay fixtures directly to junction boxes using manufacturer-supplied cords. Remember, working with electricity can be dangerous. Always to energize circuits before working on them and follow safe work practices. If you are not qualified to perform electrical work, hire a licensed electrician. Regarding the use of silk cord for aerial drops, the NEC allows the use of flexible cords for certain applications, but there are limitations. NEC 400.7 specifies permitted uses of flexible cords, and NEC 400.8 specifies uses not permitted. Generally, flexible cords are not permitted to be used as a substitute for the fixed wiring of a structure. However, they can be used for pendants, connection of portable lamps or appliances, and other specific applications. When using flexible cords for aerial drops, it is important to ensure that the cord is properly supported and protected from strain. The cord should be suspended from a messenger wire or other suitable support and should be protected from abrasion and other physical damage. Additionally, the cord should be rated for outdoor use and should be resistant to sunlight, moisture, and other environmental factors. In a specific case of using saw cord for aerial drops to equipment off a gutter, this may not be permitted by the NEC if the cord is being used as a substitute for fixed wiring. It is important to consult with a qualified electrical inspector to determine whether this installation is compliant with local codes. In general, it is preferable to use a permanent wiring method, such as conduit or cable, for connecting equipment to a power source. This provides a more reliable and durable connection and reduces the risk of electrical hazards. To summarize, when connecting high bay fixtures directly to junction boxes using manufacturer-supplied cords, it is important to consider the type of cord, the ampacity rating, the method of attachment, the weight of the fixture, and compliance with local codes and manufacturer's instructions. When using flexible cords for aerial drops, it is important to ensure that the cord is properly supported and protected from strain and that the installation complies with the NEC and local codes. Always consult with qualified electrical professionals and follow safe work practices when working with electricity. The information provided in this discussion is for general informational purposes only and should not be construed as professional advice. Electrical codes and regulations vary by location, and it is essential to consult with qualified electrical professionals to ensure compliance with all applicable requirements. Remember that electricity is dangerous. An unqualified individual should not attempt to perform electrical work. Always energize circuits before working on them and follow safe work practices. The NEC is a comprehensive document that covers a wide range of electrical topics. It is essential for electrical professionals to be familiar with the NEC and to stay up to date on the latest changes and revisions. The NEC is updated every 3 years, and it is important to use the latest edition. In addition to the NEC, there are many other codes and standards that may apply to electrical installations, such as the National Electrical Safety Code, the International Building Code, and various ANSI standards. It is important to be familiar with all applicable codes and standards and to follow them carefully. Electrical safety is a critical concern, and it is essential to take all necessary precautions to prevent electrical accidents. Electrical accidents can result in serious injury or death. Some common electrical hazards include electric shock, arc flash, and electrical fires. To prevent electrical accidents, it is important to follow safe work practices, use properly maintained equipment, and wear appropriate personal protective equipment. Only qualified individuals should perform electrical work. If you are not qualified to perform electrical work, hire a licensed electrician. Electrical inspections are an important part of ensuring electrical safety. Electrical inspections are performed by qualified electrical inspectors who are trained to identify electrical hazards and code violations. Electrical inspections are typically required for new construction, renovations, and other electrical work. It is important to obtain the necessary permits and inspections before performing any electrical work. Electrical permits are required for most electrical work and help to ensure that the work is performed safely and in accordance with applicable codes. Electrical permits are typically obtained from the local building department. The permitting process typically involves submitting plans and specifications for the electrical work and paying a fee. After the electrical work is completed, it must be inspected by a qualified electrical inspector. If the work passes inspection, the inspector will issue a certificate of occupancy. Continuing education is essential for electrical professionals. The electrical codes and technologies are constantly evolving, and it is important for electrical professionals to stay up to date on the latest changes and developments. Continuing education courses are offered by various organizations such as the International Association of Electrical Inspectors, the National Fire Protection Association, and various colleges and universities. By taking continuing education courses, electrical professionals can enhance their knowledge and skills and improve their ability to provide safe and reliable electrical services. The electrical industry is a dynamic and challenging field, and it offers many opportunities for qualified individuals. Electrical professionals can work in a variety of settings, such as construction, manufacturing, maintenance, and engineering. There is a high demand for qualified electrical professionals, and salaries are generally good. If you are interested in a career in the electrical industry, it is important to obtain the necessary education and training. There are various educational and training programs available, such as apprenticeships, technical schools, and colleges. By completing an educational and training program, you can gain the knowledge and skills necessary to succeed in the electrical industry.